Hello, 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 hello. Hi, 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 hi. Are you there? Hi, Shalini. Good evening. So there was some technical glitches, okay? Some technical faults were there. I think now everything is clear. I think we can start this session. Ante kada? Right. All right. Why is range different than height? Hey, what are you asking, Ray? Why is range different than height? Range. Good evening, good evening. Good evening, Satvika. Very good evening. It's the bottle of water. Yeah, I'll be back. Hi, hi, hi. Hi, Vijay Kumar. Hi, hi, hi. So, can we start? Can we start? Hi, hi. Hello, hello, everybody. Hello, hello, hello. Okay, okay, okay. So, I think we can start, right? Great. Work, power, energy. Na? It's the new chapter, and my target will be to finish this chapter in today's class only. Okay? Hello, 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 everybody. Hello. Hi, Sheikh Insha. Yeah, hello, 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 hello. Vijay Kumar, hi. Harshini MT, hi. Hi. Okay, sir, you look so handsome. Thank you so much, Bharat. Thank you so much. So, let us start with the topic, okay? All right. The name is work, power, energy. Okay? Hey, prerequisites undalera. What are the prerequisites that are required for you? Okay, what are the prerequisites required to go with this chapter? Vectors. Vectors is the first one. Eh? So you must have the idea about vectors. So quickly I'm writing prerequisites. Okay? Prerequisites. Deedlo, number one is you should be good with the vectors. To be honest, dot products. Hi, hi, hi. Janvi, hi. Good evening, Spandana. Very good evening, all of you. So, shall we start? If you don't have any problem, I think we can start it, right? Tell me, all of you. Can we start? Can we start? Can we start? Yes. Good evening, good evening, good evening, good evening. Hey, like the video, you know, you're not liking it enough. Just like the video once. Okay, so the prerequisites are you must be good at vectors. Sometimes, if possible, calculus also. Calculus and integration and differentiation. Okay, so let us go with integration. Right. Chuddam, andariki. Let's go. Right. Just give me a minute so that everything is set. Let me just check there is no network or technical glitches. Okay. Perfect. All right. So let us talk about the work in this scenario. Student, andariki. What is work, Ray? Sir, I just came to the class. Okay, I lifted this bag. I just took the class. I did a work, right? Work is different. You understand? In physics, when we talk about work, we will talk about only the action that could be converted into energy. Leda, the action that consumes the energy. Ade kada? Yes, yes, yes. Ante, if you're talking about work in physics, the work should be deductible from energy. That's it. Okay, that's it. We don't call anything to be work. Sir, I'm speaking. Is it work? It is actually work. If you see my mouth, if you see my jaws, if you see my teeth, if you see my tongue, they are moving. Absolutely. Okay, so the muscles are doing the work. According to the muscles, they are applying force and the displacement of the tongue is happening up and down. So that means they are doing the work. But from my perspective, I'm not doing any work. Andarki. Chudandi. Okay? Hi, hello, 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 hello. Good evening, good evening. Soya, good evening. Good. So, in physics, work is nothing but an action that is responsible for changing energy, the energy of the system. So, for example, you understand, okay, you understand. Hey, okay, Roju, there was a fat guy, okay, very fat guy. So, what he did is, he actually went to the gym. And there he came to know about biomechanics. Biomechanics and TNT, say. I have 17% of body fat. And he has huge body fat. For example, I'm telling you, okay? For example, he has huge body fat. And he took the mathematics of it. Mathematics and sir, 1 gram of fat has around, I don't know how many calories, I think 9 calories, okay? 9 calories of energy. So, sir, to burn 1 gram of fat, I have to do 9 calories of work, ra. Ade kada? Yes. Ade, right. Hey. Good, Janvi, good. So basically, work is nothing but the actions or the set of the actions that can change the energy of the system. So if you are talking about, sir, I'm just sitting and looking at some work, looking at something. So my father gave me a work, sir, to guard the house. So I sat in front of the house and I'm looking here and there. I'm doing work. No, you're not doing the work. Understanding, you're thinking something. You're not doing the work. Real life lo work and different meanings, ra. Okay? Hey, enough, right? Mahi. You don't spam. Don't spam. Okay? Later, I might have to remove you. Next. Okay. So work is nothing but the set of actions that change the energy of the system. Ade kada, right? So in physics, the scientists have observed what are the actions, sir. So for example, if you are applying work force, hey, I will give you simplest example. Okay, I will give you simplest example. You understand that example, okay? So I'm pushing this wall. Okay, I'm pushing this wall very hard, and for the whole day, I've pushed the wall only. No movement at all. And my energy is lost, right? My energy is lost, right? Yes. Hi. Miss Dolphin. Hi. Okay. So, when you are pushing the wall very hard, your energy is going. No work is done, right? I have to calculate where the energy has gone. So, initially 100 joule of energy was there in my body, right? I did the work until I wasted the energy. But I have no major. Where is the proof? Where is the proof that you have spent your energy? Understanding? Okay, Roju, you go to market. Okay, you go to market and your 100 rupees are stolen. Okay, stolen. So you come back to house and your father asks you, where is the 100 rupees? Right? For you, 100 rupees is a very simple thing. Okay, let us say you have gone to the market with 1 crore rupees. With 1 crore rupees, you went to the market and it got stolen. Sir, don't say like this, sir. Yes. So, what happened is you went with 1 crore rupees. That money is gone. Where is the proof? No proof. No proof, right? So, it's gone. It's stolen. That is the reason why we don't include such systems in our ITRA. So, you took that 1 crore rupees. You bought this much big of diamond, okay? You bought this diamond and you show to your father. See, chudandi, Nana garu, this is the diamond that I bought. So the 1 crore you gave me, this is the proof. But if that 1 crore is gone, where is the proof? No proof. Understanding? Hi. No proof. No proof ante entira. We don't consider those to be in our systems, right? So physics is a world where police system is very strong. Understanding? Police system is very strong. We don't consider the cases of getting stolen at all. Chuskondi, I'll tell you, okay? So, this is our guy. This is a person. Let us say Ramesh. Okay? He has 100 joule of energy. Chuskondi. So now, he is telling that I have full energy. I want to waste it. I want to spend it. Not waste. Not waste. Spend it. I want to spend my energy. Okay, I want to spend my energy. Where should I spend? Where should I spend? Where should I spend? So he said, hey, listen to this story very carefully, okay? I know it's not that entertaining, but listen to it. Listen to it. So he said, hey, I have energy. So I'll push this block. So he pushed it. Let us say 100 kg of block is there. Chudani andariki. 100 kg of block is there. He started pushing the block. The block got displaced by 1 meter. Ante kada? Yes. 100 kg of block. Displacement is 1 meter. Andarki chudandi. What is work done? Don't say. In moving this block by 1 meter, his entire energy is gone. Mottam energy aipoindi. So he said, hey, I'm very tired now. I'm very tired now. Where is the energy gone? What is the proof? Proof is modatiga, this 100 kg block was here. Finally, this moved here. So the motion of 100 kg block is the proof that he spent his energy. Understanding? His energy is gone. And the proof is this. The block has moved by 1 meter. On the other hand, chuskondi, andariki. So the same person is there. He has 10,000 joule of energy. 10,000, 1 lakh. 1 lakh joule of energy. So what is doing? He is pushing this wall, right? He is pushing this wall. Pushing it very hard. 5 minutes tarvata, complete energy gone. Energy gone kada, energy completed. But the wall didn't move. Wall is there only. So his father comes and asks him, hey, where is your energy? He said, I spent it. What is the proof? Wall hasn't moved. Understanding? Wall hasn't moved. What is the proof? So he has no proof. Ante his father will think he has lost that energy. Ante someone stole it. Understanding? So physics law, these stealings and all these things, they are not there. So we need a way to express the change in energy successfully in some other form. Understanding? That is the reason why we talk about work in physics. Chuskondi andariki. In physics law, we need the successful proof that the energy has been transferred. Ante kada? Proof. Yes. Yes, you can listen to it. So physics law, you can say the proof. Proof is, sir, block has displaced and energy has gone. Understanding? So displacement into force is known as Chapandi. So work is equals to force into displacement. They have designed this formula. Some scientists, some idiots, their brain was completely rotten, came with this formula, gave us, we are studying. Nothing. Okay. Yes, go ahead, yes. If wall is not moving and work done is zero. Practically, energy is gone. Okay, energy is gone. Yes. Adi Lakshmi, you can listen. If wall doesn't move until work done is zero, where is the energy gone? Gone. Where is it gone? In the muscles. Understanding? Someone, this sound energy gone. Understanding? Some person may get heated, body completely heated. Ears becomes red hot. that heat energy, total energy has converted into different forms. Ade kada, but work done is zero. Okay, good. Work done is zero, but energy is lost. Stolen. Energy is stolen. Okay, not useful. Evaporates. Yes, something like this. Okay, energy is evaporated. So work done should be in a very smart way. Chuskondi. If at all you are wasting the energy, that is the wastest thing, not bestest. Wastest thing you could do in physics. Ante you're losing money, ra. Energy is nothing but money in language of physics. Okay, so if you are losing energy, ante you are losing crores of rupees. We don't want to lose the energy, right? We have to keep the track of each and every single joule of energy, whatever we are studying. Okay. Next. So some scientists, they came at a place. They said, hey, I want to express, I had 100 joule of energy. Hey, I had 100 joule of energy. 100 joule of energy was there. Student yandariki. Mottam energy, work, hey, it has been completed into work. Ante kada? Yes. So 100 joule of energy was there. Eppudu we have to see, చూద్దాం అందరికి, what type of energies are there, how will it change, forces, types of forces, conservative, non-conservative, potential energy, expressions for different forces, అందరికి చూద్దాం. Okay. So 100 joule of energy has been converted to 100 joule of work. చూసుకోండిరా. This is the best thing. This is the best thing until no energy has been lost. No energy has been lost until what should it? Stolen. Every joule has been recorded on paper. 100 joule of energy was there, converted to 100 joule of work. We don't have any energy loss in this. Chuskondi. Another scenario lo మీ దగ్గర 100 joule of energy is there, but only 40 joule is converted into work done. మిగతా 60 joule తెలియదు, gone. So his father will, right? Yes. Understanding? So he is not a good guy. Okay, this is not a responsible person. This is a responsible person. He is conserving all the energy. Ante kada? Yes, we will come on it. Okay, one by one చూసుకోండి అందరికి. So what is work done, right? Work done is nothing but చూసుకోండి. Now we will take different cases, right? చూడండి అందరికి. So this is a block. Okay, so this is a block. Let us say mass is 40 kg. అందరికి చూసుకోండి. And this is a person. He is applying a force. F is equals to, let us say, 50 newtons. Ante kada? The block has been displaced by 10 meters. In second scenario, same 40 kg block తీసుకున్నారు. చూసుకోండి అందరికి. 40 kg block. అదే same block. కానీ the direction is different. Direction అంటే సార్, direction of application of force. చూసుకో. So ఇప్పుడు this guy said, hey, I am applying force straight. Now I got some extra energy. So let us do one thing. So he is standing on a big chair. Okay, he is standing on a big chair. He is standing on a big chair like this. And he is applying force like this. Andarki chudandi. He is applying force in a cross direction. Okay, something like this. Good. So same force, okay, 50 Newton, same force he has applied, 50 Newton, kani with an angle of 60 degrees to the horizontal. Hey, are you understanding the situation? Same force, 50 Newton, kani at an angle of 60 degree to the horizontal, something like this. So now what will happen, right? Now what will happen? Cheppandi andariki. Now what happens is, this force is gonna resolve. Yes, 50 Newton of force, 50 Newton of force is getting resolved in two different directions. First one, idina, second one. Ante kada, ee angle 60 degree unte, you can simply say 50 cos 60 under 25 Newton ra. Ekkada chudandi, this will come as 25 root 3 Newton. Ade kada? Yes, resolution of vectors. Good, very good. 25 root 3 and approximately you can take 5 and 42.5 Newton ra. This is 42.5 Newton. Now my question to you is, చూడండి అందరికి, who is more responsible person, this or this? Ante where is energy getting lost, stolen, and where the energy is getting conserved? Cheppandi. Conserved ante 500 joule complete transfer, 500 joule of work. Lost ante మీ దగ్గర 500 joule ఉంటే you are some losing some, you are transferring some. Here. In this scenario, this force ray 42.5 Newton. What direction? Kinda. So do you think any displacement is going to happen? No displacement. Ante this force is waste. It is just like pushing a wall, but in the downward direction. You push the ground with your complete power. Nothing is gonna move. Understanding? Nothing gonna move ante this force is wasted, ra. Understanding? Wasted. So let us say whatever amount of energy he had, for example, hey, let us talk about here in the scenario. Cheppandi. Work done how much? F into S. Ante 500. So he had 500 joule of energy. Mottam 500 joule has been converted to work done. Ade kada? Right. Ekkada cheppandi. Force is how much? 25. Okay. How much displacement covered, ra? How much displacement covered? Cheppandi andariki 1 meters. Ade kada? Right. So in 1 meter of displacement, how much of work is done? Only 25 joule of work is done. Ade. Here 500 joule work done, and here only 25 joule. Ante 475 joule is lost. Understanding? Yes. 475, not 10 meter, not 1 meter, okay? 10 meter, sorry. So it is approximately equals to 250 joule, okay? 250 joule ante half of the energy is lost. Chuskondi andariki. Hey, am I doing correct? Yes, I am doing correct. Chappo. So 250 joule of energy is converted into work. Here 500 joule was there, entire 500 converted into work. Kabatti we only talk about work here. So physics, what does it say? Hey, how much is lost, Ray? How much is lost? 250 lost kada? Lost. We don't talk about it. Understanding? So what does physics say? Physics tells you, hey, how much work did he do? 500. How much work did he do? 250. Ante he had initial energy of 250 only. Hey, although he had 500 ray, we are not concerning about this energy. Okay, so what we will say? We will say that this idiot, he started with 250 joule of energy only, and he has converted entire energy into work. Understanding? We are hiding his mistakes. Ante kada? Yes. So first one is conserved. Conserved ante entire energy converted to work done. Second one is lost. Are you understanding? Here, whatever he had, he has utilized in the best way. Understanding? That is why we need vectors, ra. So the scientists came with this terminology, W is equals to F bar dot S bar. Why dot product, sir? Why dot product? Because dot product is the only tool that considers the force and displacement in the same direction. Understanding? Chuskondi. So if you say here, Chappora, how much work did he do? Sir, force enta 50. Sir, displacement enta 10 into cos theta, AB cos theta, A bar dot B bar kada, F bar dot S bar ante F into S into cos theta. Cheppandi. Cos theta ante cos 60 kada? Yes, cos 60 is half. Ante 250 joule. Ante entira. That means this formula is only considering the successful work, ra. The wasted work is not considering. Are you understanding? E formula F bar dot S bar, ra. This formula only considers the successful work done. It ignores any useless or any waste work. Are you understanding? Good. Yes. So you can say that to calculate the work, force and displacement must be in the same direction. Ledante you have to consider the component in the perpendicular directions. Eppudu the component could be of force leda for displacement. Okay, you can take the components also. Right. Okay, చూసుకోండి. You have work is equals to F into cos theta into displacement. F cos theta అంటే ఏంటిరా? F cos theta అంటే పర్పెండిక్యులర్ కాంపోనెంట్ ఆఫ్ ఫోర్స్ కదా. ఎస్, F cos theta అంటే పర్పెండిక్యులర్ కాంపోనెంట్ ఆఫ్ ఫోర్స్ in direction of displacement. అదే రైట్. yes perpendicular component of force in the direction of displacement into direction s displacement, లేదా you can say work is equals to F into S cos theta. అంటే ఏంటిరా? ఫోర్స్ ఇంటూ పర్పెండిక్యులర్, చెప్పండి అందరికి, ఫోర్స్ ఇంటూ పర్పెండిక్యులర్ కాంపోనెంట్ ఆఫ్ డిస్ప్లేస్మెంట్, అంతే కదా. ఎస్, ఆఫ్ డిస్ప్లేస్మెంట్ in direction of force, in the direction of force. Other good, big bracket ra, something like this. I hope it is understandable. Okay, so ipudu let us talk about some questions re. Cheppandi andariki. Now that you know work done is completed, right? Work done is completed. Complete ante enti ra? చెప్పండి అందరికి. If glitch hey, am I audible? Am I visible? Is it clear? Everything clear? Or is it glitch? Okay. చెప్పండి. ఫోర్స్ ఆఫ్ 2 న్యూటన్, ఇదే నా ఫోర్స్. F is equals to 2 న్యూటన్, అంతే కదా. ఎస్. అండ్ డిస్ప్లేస్మెంట్ ఆఫ్ బై 4 మీటర్ at 30 degree with the force ra. So this is the displacement is equals to 4 meter at an angle of 30 degree with the force. అదే కదా. ఎస్. చెప్పు మరి వర్క్ డన్ ఏం తీరా? వాట్ ఈస్ ద వర్క్ డన్ అందరికి? టెల్ మీ రే, డోంట్ సిట్ సైలెంట్లీ. Good. Sir, work done is equals to F bar dot S bar. అదే కదా. Yes. F bar dot S bar రా. చెప్పు. అంటే Fs cos theta అంటే ఏంటిరా? ఫోర్స్ వాల్యూ 2, డిస్ప్లేస్మెంట్ వాల్యూ 4, cos theta అంటే cos 30, అదే కదా. Yes, cos 30. That is equals to 8 into root 3 by 2. That is equals to 4 root 3 joule ra. It is my work done. Chuskondi. Again I'll tell you. Okay, good. Again I will tell you, this displacement has two components. Andariki chudandi. This displacement has two components. Ide na first component, this is the second component of displacement. So this component is wasted ra. Wasted. Okay, it's not perfect condition for us. This component has been wasted. Ante kada? Yes. Yeah. No problem. ఓకే, చూసుకోండిరా. ఇప్పుడు లెట్ us talk about some other things. Okay, work, it has two cases. Number one, work done by constant force, లేదా work done by variable force, అంతే కదా. Yes, so variable force. So if it's a constant force, no problem. It's a constant force, no problem. We can simply say, sir, W is equals to F bar dot S bar. Adhe kada? Yes. You can say that. We will be, yeah. Hi, Parimala, hi. Okay. So we'll be going to solve questions. It also has rendu modu rakal questions. Okay? It has 2-3 types of set of questions that we have to discuss each and every one of it. Similarly, variable force unte, you can simply say work is equals to integral of F bar dot dx bar. Chuskondira. It's a very important thing, okay? It's a very important thing. I'm telling you again and again. Malli cheptunnaru chuskondi andariki, okay? So work is equals to f bar dot s bar ra. F bar dot s bar. F bar dot s bar. F bar dot s bar. Are you able to understand something? Are you able to understand? I will tell you. I will tell you. Chuskondi. So let us take a question ra. A force F is equals to 2i plus 3j plus 4k acts on a particle. Ade kada? Yes. And changes its position from 1, 2, 3 to 2, 4, 6. Full stop. Find work done. Constant force kada chudandi, constant force re, constant force. Edigo teeskondi. Okay, you can take the question andariki. So sir, work done is equals to, hey, where should I write, Ray? I don't have any space left. Okay, let us zoom it out. Let us zoom it out a little, something like this. Right, perfect. Perfect. Cheppandi andariki. So f bar ki value entira? I'll write the solution with different color. Okay, sir, f bar is equals to, cheppandi, f bar is equals to 2i plus 3j plus 4k. Kani I don't have s bar ra. F bar dot s bar kada? S bar. Naku s bar kavali andariki. Cheppandi. S bar value entira? Sir, S bar is equals to, చూసుకోండి రే అందరికి, R2 bar minus R1 bar రా. Why are you writing, sir? Why are you writing this, sir? R2 bar minus R1 bar. Vectors, position vectors. గుర్తుకు. Try to remember that రే. గుర్తుందా? మర్చిపోయింది. Yes. So R2 bar minus R1 bar ante, you subtract I from I, J from J, K from K. So 2 minus 1 becomes 1. 1 into I cap ra. Okay, plus 4 minus 2, 4 minus 2, 4 minus 2, 2 j cap, 6 minus 3 ante plus 3 k cap. Ade. So this is my s bar, this is my f bar. Take the direct dot product. Okay, take directly the dot product. W is equals to f bar dot s bar ante cheppandi f bar value entira? 2i plus 3j plus 4k dot I plus 2j plus 3k. Ante kada? Multiply I with I. 2 into 1 becomes 1. Plus 3 into 2 becomes 6. Plus 4 into 3 becomes 12. And 19 joule of work has been done. Ade kada? It's a very good question actually. Good. Very good. Okay. No. No, work done is not in IJK form. Okay. No, it's not in IJK form, ra. 2 into 1, 2. Sorry. 20 joules. Okay. 20 joules of work, ra. Andariki. So 2 into 1 is 2, plus 3 into 2 is 6, plus 12. So it is equals to 20 joule of work. It's not in IJK, vector form. Dot product is not IJK. Dot product is a scalar quantity. Okay? Hi, Prissy. Hi. Hey, dot product is a scalar quantity. Multiply I with I, J with J, K with K, and add all of them. Okay? Yes. Welcome. आइए, आपका इंतजार था. Okay? There is entire song रे. आइए, आपका इंतजार था. देर लगी आने में तुमको. शुक्र है लेकिन आए तो. Good. Janvi, very good. ఇప్పుడు చూడండి. If the force is a variable force, in that case, how will you do it? So simply say, let us say a force F is equals to 2x I cap plus 3y square j cap plus 4z k cap is acting on a particle. Ante kada? Yes, on a particle ra. And displaces, okay, and displaces it from చెప్పండి అందరికి origin అంటే 0,0,0 to some random point cheppu 2,6,8 అదే కదా. Yes, find the work done. Okay? Find the work done, right? Yes. Okay. Yeah. 268. Find work done. Ela find cheyalira. You remember the method, all of you. Okay? All of you. Although these questions are not required for you. Okay? These are for JE, specific JE. Kani, your 25 question paper chusava. Huh? How is it? Butter. Okay? NEET 2025 was butter on a sandwich. Okay? On that there was green chilies. And then on that there was red chilies. And on that there were, cloves, everything. So yeah, it was a very tasty paper. So that is the reason why we are practicing. Okay, next, choose good. This was the force rate. Displace the particle from origin to 268, 2,6,8. Taku work kavali. So how to do it? I will tell you. Okay, I will tell you. Don't worry. I will tell you. First of all, break the forces in different dimensions. Dimensions under IJK. Similarly, break the displacement into dimensions. Ante kada? Yes. Different forces, different dimensions. Cheppandi. Sir, force ki value enti ra? Sir, F is equals to, cheppu, 2x I cap plus 3y square j cap plus 4z k cap. Ade kada? Right. Ante in x axis, y axis, z axis. Right? Good. Now, let us talk about displacement. S bar. Cheppandi. So it is 2i plus 6j plus not. Hey, you don't have to do it like this. Okay? You don't have to do it like this actually. You don't have to go with the regular method. Choose kondi. So now you can simply say work is equals to integral f bar dot ds bar. Ante telusa f bar ante it has three components kada, fxi, fyj, fzk dot ds. It also has three vectors, dx, dy, dz. Adera, you take the dot product ante. So it comes out to be integral of fx I cap plus fy j cap plus fz k cap dot dx I cap ade kada plus dy j cap plus dz k cap. You remember dot product? Do you remember how do you do the dot product? Do you remember? Yes, sir, we remember. Multiply I with I, multiply j with j, and multiply k with k. Ade kada? Right. Chappura. So integral of x dx plus fy dy plus fz dz. Ade kada? Yes. Separate ga raskondi. You write the separate integration in front of everybody. Cheppandi andariki. So what do you get? Sir, w is equals to integral of fx dx. Fx ante horizontal force ra. Hey, fx dx plus cheppandi andariki plus integral of fy dy plus integral of fz dz. Ade kada? Right. What about limits? Limits gurinchi cheppandi andariki. Limits. Initially x axis lo 0, final limit 2, 0 to 2. X axis lo limit 0 to 2, 0 to 6, 0 to 8. Ade 0 to 2 for x, 0 to 6 for y, and 0 to 8 for z. Ade kada? Ippudu value substitute cheskondi. Fx value enta ra? Fx value is 2x. Ade kada? Right. So sir, it is equals to 2x dx plus fy value enta ra? Sir, fy value. Fy is 3y square plus 3y square into dy plus integral 4z dz. Ade kada? Dz. Right. So 0 to 2, 0 to 6, 0 to 8. Good. Substitute. Tell me value. 2x integral becomes x square. Limits are from 0 to 2 plus 3y square integration. Cheppandi. It is y cube. Limits are from 0 to 6 plus 4z integral ra. It is 2z square. Limits are from 0 to 8. Ade kada? Right. Substitute cheskondi ra okkasari. Sir, 2 square ante 4 minus 0 is 4 plus sir 6 cube ante 216 minus 0 cube is 0 plus 8 square 64 into 2 becomes 128. Ade kada? Yes. Cheppandi. So sir, 216 plus 128. 216 plus 128? 216 plus 128. How much, Ray? How much? How much? How much? Sir, 4 plus 6 becomes 10. 10 plus 8, 18. Carried is 1, sir. 3 and 1, 4, sir. And 2 and 1, 3, sir. So, this is our work. Sir, we are class 8th students. So, we are doing this by unit, tens and hundreds of places. 216, sir. 216, not 216. Okay, so, it is 348. Hey, am I correct? Choose Kondi. Okay, I am correct only. I can't do wrong answers. I am the best. I can't do wrong. This should be our attitude. Next, work done by constant force, finished. Work done by variable force. How many students are there? Yes, finished. Now, let us talk about different cases. Different cases. What cases, sir? Not 500. Karthik, how 500? How 500, Karthik? Are you observing everything? 64 into 2, 128. 216. 4. Ade kada? Right. Next. Hey, choose konira. చెప్పండి పాజిటివ్ వర్క్ అంటే ఏంటిరా పాజిటివ్ వర్క్ అంటే దెర్ ఈస్ సమ్ లిమిట్ ఓకే దెర్ ఈస్ సమ్ లిమిట్ అందరికి చూడండి దెర్ ఈస్ సమ్ లిమిట్ టు వాట్స్ డైరెక్షన్స్ ఏం డైరెక్షన్స్ సార్ వాట్ డైరెక్షన్స్ ఆఫ్ ఫోర్స్ అండ్ డిస్ప్లేస్మెంట్ ఇట్ హ్యాస్ సమ్ లిమిట్ అంటే ఏంటి చూసుకోండి అంటే ఇఫ్ అట్ ఆల్ యువర్ బ్లాక్ ఈస్ లైయింగ్ లైక్ దిస్ ఐమ్ టేకింగ్ ఎన్ ఎగ్జాంపుల్ ఆఫ్ అ బ్లాక్ రా ఓకే ఒక బ్లాక్ నీ ఎగ్జాంపుల్ ఐమ్ టేకింగ్ ఇట్ హియర్ చూసుకోండి లెట్ us say the mass is 10 kg అందరికి mass is 10 kg and I am applying the force like this, ra. Chusko. Not like this, Ray. I am applying force something like this. Okay? Before that. Hi, Teja. Hi. Before that, let us say the displacement is in the right side. Andarki chuskondi. Displacement in the right side. Good. Limits for work for positive. Hey, limits of force for positive work. Andarki chuskondi. I am interested about limit of force for positive work case ra. So the limit of the force range is this. And this is the limit. Until you apply force like this, best case, absolutely best case. If you are applying force like this, okay, no problem. If you are changing it, no problem. Positive work. If you cross it, then it will become negative work. Ante kada. ఒకసారి మీరు 90-degree యాంగిల్ చేంజ్ చేస్తే క్రాస్ చేస్తే ద వర్క్ విల్ బి నెగటివ్ వర్క్ సో సార్ పాజిటివ్ వర్క్ లో యాంగిల్ థీటా బిట్వీన్ యువర్ ఫోర్స్ అండ్ డిస్ప్లేస్మెంట్ ఓకే థీటా ఇట్ షుడ్ బి ఫ్రమ్ 0 to 90 degrees అదే కదా వాట్ ఈస్ ద సిగ్నిఫికెంట్ ఆఫ్ పాజిటివ్ వర్క్ రే వాట్ ఈస్ ద సిగ్నిఫికెన్స్ ఆఫ్ పాజిటివ్ వర్క్ The significance of positive work is that increases ade kada increases the energy of the system. That energy could be by your kinetic energy or potential energy, ante kada. But whenever there is positive work done on the system, it is simply going to increase the energy. Negative work entira. Negative work lo I am taking again the same block mass problem, okay? Chuskondi andariki. So this is my same block of mass 10 kg andariki. Your displacement is also in the right side. Okay? So idi me displacement ra. Kani the direction of force it has been crossed. Ante this angle theta ra force. So theta should be more than 90 degree. Okay, 90 degree is less than theta is less than 180 degree. It is known as negative work. Okay, it is known as negative work. Yes, Satvika, very good, very good. So negative work actually decreases the energy. Negative work ante has been lost, money is gone from house rate. Negative work ante entira, it is in the depth. Money is lost ante work is lost ante it has decreased the energy. Friction, example. Negative work ante I'll tell you each and every force by example. Okay, friction forces చూసుకోండి. So whenever there is a negative work, negative work decreases. Negative work decreases the energy of system. Oh, right. And it is the useless case, the most useless case. Zero work ante it is the most rascal son of the house. A father has 3 children. Positive work, topper, studying daily, responsible guy, doing his work on time. Okay, this is a positive work. He waste guy ante sleeping till 3 p.m. in the afternoon, drinking cigarettes, alcohol, drinking, complete loss. Energy is gone from the house. Money is gone from the house. This guy, he is studying guy, he has got a job now. He is earning 2 lakh rupees, 3 lakh rupees, 5 lakhs a month. And he is, a very responsible person. Completely formally dressed and all these things. He is a very good guy. Positive work. You understand? Zero work. Zero work is like, zero work is, how should I explain you, right? He is doing a lot of work, right? That movie, right? Race Gurram చూసా అందరికి. దీంట్లో అల్లు అర్జున్ doing a lot of work, but it is not visible to anybody. Okay, doing a lot of work, but it is not visible. So everybody thinks he is the waste fellow, but he is working so hard. Okay? But his work is getting completely wasted. Zero work, kada? Zero work. Nothing proof. No proof at all. Okay? No proof at all. And the displacement and the force should be at 90 degrees. Theta is equals to 90 degrees. Ade kada? Yes. Theta should be equals to 90 degrees. Okay? Even if the efforts are there, even if the efforts are there, the energy is neither gained, neither increased, nor decreased. Ante kada? Yes. Neither increased nor decreased. Zero work example, okay? Yes, theta is equals to 90 degrees. Good. Okay? Right. This guy, for example, someone, okay? So you went to a railway station, you took a coolie akkadi nunchi. Vaadu, he is lifting too much heavy objects and placing on his head and walking. Walking. Physics law, his work is zero. He is holding that objects. He is holding everything, whatever he is holding. The force that is applying. So this is the book. I am applying like this. Chusko. I am pushing it upwards. I am pushing it upwards. But the displacement is in the forward direction. Displacement, force. 90 degree angle kada? Yes. 90 degree. Ante work done is zero. Okay. Work done is zero. Best example, best. Okay, best example. If you are carrying something, you are applying force in the upward direction and displacement is in the forward direction. And work done is zero. Okay? Carrying something has zero work. Good. Next. Let us talk about questions. Questions ante questions for different scenario, different works. Andariki ardham chesukondi. Okay? Very important now. Very important. Very important thing. Question number 1. Hey, what happened?